Hello, everyone. Welcome. This is a new series called PSC Showcase, where we will have some PSC projects presenting. And you can go to the website, the PSC website. The URL is psc.dev and take a look at the list of projects. The projects are in psc.dev/projects. And this is the first session. This will be recorded. So the first session, for the first session, we have Gautier, who will be presenting AnonKlub, and you can ask questions during the presentation in the chat, and at the end of the presentation, you can also ask to speak and ask questions too. So yeah, Gautier, the floor is yours. You can start when you want.
Thanks, Vivian. Hi, everyone. I don't know how many people there are in this call, but I think I can safely assume that some of you have already been eligible for an airdrop. And if you value privacy, you probably wished back then you had the possibility to anonymously receive your airdrop tokens instead of being coerced to reuse that address that was included in the airdrop snapshot. And AnonKlub is exciting because it enables these kind of applications. I'm Gautier, I'm an engineer at PSC, and I will talk about what challenges AnonKlub is trying to solve, how it's built, and show a quick demo. Before we dive in, I will assume that you've encountered the terms on this slide. I will not explain in details what they are, but if you consider them as black box and you have an intuition about them, you know what's coming in and coming out, you should be fine for the rest of this talk. Along with anonymous airdrops that I mentioned, applications such as anonymous chat groups, anonymous voting, mixers, or anonymous NFT minting all require you that you're a member of a group, especially that you the address you own is part of a list. And to make this first check, this is a Merkle proof. This is a well-known problem. And then you need to prove that you own this address that you checked that is part of the set. And this is an ECDSA signature. And the main challenge, so when we think about privacy, is that from the signature data, you can recover the public key, and then you can recover the address. And by definition, public is not very private. So yeah, you cannot build these anonymous applications just like this. So what do you do? You think about ZK Snark and you say, yeah, let's put this ECDSA signature and the Merkle proof into the Snark, and then we have everything private. This is what we wanted. You're able to, if someone gives you a list of addresses, you can convince him that you own an address which is in the set without telling him which one. And this unlocks all the applications you see at the top of this slide. Now, the main difficulty comes from the fact that computing ECDSA signatures into a Snark is complicated due to something called wrong-field arithmetic. The most common proving frameworks involve pairing cryptography that require pairing-friendly curves, like BN 254, that, as the name suggests, has a 254 bits length size. But the stuff you want to prove you can do within the Snark, the ECDSA signature involves a curve that has 256 bits. So ECCP 256K1 for that. And this mismatch of bits is bad because it requires you to do this wrong field arithmetic. A good comparison to have an intuition is, think about a long tweet that you need to split in a lot of different chunks. It's a lot of extra work, it's complicated, and it just makes your circuit bigger, and it's bad for proving and verification time. And what some people have done is sidestep this difficulty by using Snark-friendly curves. And then you get applications such as Semaphore or Tornado Cash. And a significant drawback of these protocols is that they require interactivity. What happens there is that there's a sign up step. You need to register your nullifier, and then the anonymity set size is only equal to the number of people that have signed up before you. And this is very limiting because the first person that interacts with the protocol will have much less anonymities than the last person. And with AnonKlub, we want to build something where we have access to the full anonymity set immediately. And for this, you need to constrict your anonymity set beforehand, and you need to deal directly with ECDSA signature and nullifiers within the snark. Here is a list of tools for building ZK ECDSA that we explored. The initial version of AnonKlub was built with Circom ECDSA. The good thing about Circom is that the tooling is mature and it's a bit easier to start with regard to circuit writing complexity, and it supports on-chain verification. The drawback is that it does wrong fit arithmetic, so the circuit is quite big, 3 million constraints in our case, and we had a proving time of 10 minutes, which means we needed a dedicated proving server. For privacy applications, server-side proving is bad because you don't want to leak a link between your proof inputs and the proof itself. And to fulfill that need of generating proofs client-side in the browser, Personnel Labs built an optimization of Circom ECDSA called efficient ECDSA, and then something even faster called Spartan ECDSA that uses, well, Spartan and a fork of Circom. This fork allowed them to pick a curve that is compatible with right field arithmetic, and then you get a much smaller circuit and faster proving time. And this is what we use in the current version of AnonKlub. We're able to build proofs in the browser in 20 seconds. But unfortunately, we lost the ability to verify proofs on chain. And so now we're about to leave Spartan and rebuild everything with Halo 2 so that hopefully we can tick all the boxes, which are client-side proving and being able to verify the proof on chain. How AnonKlub is built. So I mentioned the previous tools before. And there's a query server that we use to fetch all this list of addresses that match different criteria that you can define. For instance, you can decide to fetch all the addresses that own at least a given balance of ERC20 tokens, or fetch all the addresses that have voted for a given decision for a DAO. And we use different data providers for this. We use June, the Graph, and Google BigQuery. Then to build the Merkle tree, we use a Rust crate that we then package in WASM, and then we wrap this into a web worker so that we can put it in our web app client. Same for the Spartan proof. So first we have a Rust crate that we package in WASM, and then we put this in a web worker. And then you get a web app that you can access at this address. And I will now show a quick video. I won't do this live because I don't believe in the demo god. Okay. So first you will be asked what kind of proof you want to generate. Or what kind of anonymity set you're interested in? Do you want to fetch a list of addresses, like I mentioned, that own a given balance of a given asset, some ETH or some ERC20? Or do you want to prove you own an NFT of a given collection? Then you just input the addresses of either the ERC20 contract, the minimum balance. Otherwise, you can also upload a file directly if you prefetch the data you want. And this is what I'm doing in this demo. Then you sign a message. And then your proof is being generated, and it takes I know the Merkle tree was built first, so it took 2-3 seconds. And now the proof will be built, and this takes a bit more time, 15 to 20 seconds. And then you get your result here that you can either copy or download. And then once you have this file, there should be services that will ask you to upload it, and then they will verify it. So I don't demo this verification step in the demo because it's not very exciting. Then next slide. What we plan to work on next. So I haven't touched so much on the nullifiers. So it's one of the main difficulty we face. So if you don't know what a nullifier is, you can compare it to a nonce for transactions. It prevents you from doing something twice. In the case of ZK proofs, or it prevents you from reusing the same proof twice. If you think about this anonymous airdrop use case, you don't want people to be able to claim their tokens twice. So you people are anonymous, but you still need to be able to tell them people apart. So you need a nullifier, and nullifiers need some specific properties like being unique, deterministic, only require the public key to be verified. In the case of ECDSA, it's a bit hard because ECDSA involves some randomness. And the most promising solution for nullifier in the case of ECDSA is Plume. But Plume, to build a Plume signature or Plume nullifier, you need access to the secret key, to the private key, and it means you need to tweak the wallets, and there aren't wallets supporting it yet. So it means we wish we could use Plume right now, but instead we will do something simpler and not as robust in terms of security, like just hashing the public key. Then, as I mentioned, we plan to migrate to Halo 2. We had already a Discord bot back to when we were still using Circom. This Discord bot is asking the user to upload a pre-generated proof, and then it will allow you to the server. And, it's a way to build anonymous Discord servers. And then a CLI, because I think it's important to have tools you can use offline to generate the proof. So the web app is nice, but actually you should be able to build the proof offline if you already have the anonymity set you want to deal with. And yeah, this is the organization on GitHub is AnonKlub, and our main repo is also called Anon. And that's it for my presentation. Thank you all for listening. And that's it.
Thank you. Thank you so much. Feel free to ask questions. Everyone can ask questions, can unmute themselves and ask questions. And representation, by the way. Really interesting. You can also ask questions in the chat as you prefer. And so we have one question. Reasons for moving to Halo 2.
So the main reason is because with Spartan, we aren't able to verify proof on chain with the verifier smart contract. And for to have a more trustless application, it's something we want to have.
Great. Thank you for that. There is another one. Which configuration of Halo 2 PSE fork with BN254 are you using?
If I'm not mistaken, this is what we are using. Halo 2 wrong, but there's Iskandar working with me on AnonKlub also in the meeting. Maybe he can add more detail, better answer this question than me.
Hey everyone, yeah, we're using PC version of Halo 2 and also Halo 2 Rung that has some crates that are already pre-built chips for ECDSA and Halo 2. We're mainly gonna depend on Zigbee 256K1 and not R1 for the questions from OneSip. Maybe we'll take a look at this later. About this random the random generation of the curve, but this is still in progress.
And ECCP 256R1, so we focus on dealing with Halo 2 with the K1 curve, but I would like also to support this curve because obviously I'm also thinking about mobile devices. But then what I know is that Plume is not compatible with mobile devices because iPhone won't let you access so easily the private key. So if we build something for mobile, then we cannot use the best nullifier we know. So we need to use something which is a bit worse. And then it's all about trade-off that what we want to build next.
So are there any applications using it right now?
Again, sorry, can you repeat?
So have you seen any application using AnonKlub right now?
Applications integrating with AnonKlub or?
Yes.
Don't think so. No.
So it can be used in real life, like an application, and it will work fine.
So there's the web app you can use already. Then if you want to build with it, you can use our libraries and integrate it in your own app. And the next question. So next big plans for AnonKlub. What I'd like to roll out is refactor this Discord bot and really have it live somewhere, maybe at PSE, so that each people at PLC would need to communicate at the AnonKlub project or me one address, and then this would be the PSE anonymity set, and then they could join anonymously a Discord server, and we would not know who has joined.
Great, super interesting. Thank you. Are there any other questions? Right. Okay, if there are no more questions, so we can wrap it up here. Thank you so much for presenting, Katja, and everyone for attending, and have a nice day for all of you. Thank you.
Thanks for having me. Thank you.
Thank you. Bye-bye.